this little thing may seem to look like some kind of a sensor, like a temperature measuring sensor or electromagnet, but in fact it's something quite different, something more interesting, something more physical. What it is a vibration motor, the same kind you can find, for example, in Xbox controllers, PS controllers, or our custom controllers. And in this video we are going to go step by step and break down how to control it, what's the software and the hardware behind the controlling, and the placement of these vibration motors in my two custom controllers. So let's get started. Firstly, let's just see how the vibration motor acts when connected to power supply. This one is specified for 3.3 volts, but it can tolerate about 3.6 volts, what is inside the battery. So there shouldn't be any problem. Let's just connect it to the positive and the negative pole. Let's see what it does. You can see it vibrating nicely. Pretty good vibrations for such a small motor, and it's pretty efficient. It consumes about only 20 or 10 milliamps, if I'm not mistaken. It can be found in the datasheet somewhere. So pretty good. Our system on both of these controllers run on 3.3 volts. So that's exactly what we are going to power this motor from. With both controllers opened up, we can have a look at the placement of the vibration motor inside the controller. Let's firstly have a look at the first version, where we can see here is the first one, the first vibration motor. Here in the top right corner is the other one, and then they are basically mirrored across the center, again here and in the upper left corner. So right here we have 1, 2, 3, 4 vibration motors. Instead of having just one big vibration motor in the middle, I decided to go for this approach of having smaller vibration motors in basically all 4 corners of the controller, so that you can, when you have the controller in hand, you can feel which vibration motor, or where is the epicentrum, from where are the vibrations coming from. Meaning that instead of having just like one source of input, you have now 4 sources of input. And the same goes for this updated version. Right here they are just and the same goes for the updated version, where again there are 4 vibration motors. Here is the first one and the second one right here underneath the PCB. You can see that it's basically the one part of the vibration motor is here, and then again here is the second one from the bottom look, and again it's mirrored across, like it's mirrored across in the halfway. So we again have it on the right side, down here and up here, and again it creates vibrations from 4 different areas. So it's a bit hard at the beginning to recognize from where it's coming from, but after some practice and after just getting to know how it feels, after maybe 20 or 30 minutes, you really start to get the hang of it, from where the vibrations are coming off. And the controlling is basically the same with both of these controllers. I just made a mistake on this PCB, and then I fixed it in the next version, so let's talk about that one small difference. And the problem with this version is that as I started, you'll notice that the vibration motors have also started, just for maybe half a second. Again, and it also happens when I restart the ESP32, or if I put it into boot mode. Yeah, and this happens because I am controlling them, the vibration motors, through MOSFETs, through transistors, and on this version I forgot to include pull-down resistors on the inputs of the MOSFET. So when the ESP32 doesn't actively turn it down, so when the code isn't running, it's acting like it's basically acting like there is a high input, so it lets the power flow. That's why it starts those vibration. That's why those vibration motors receive power and vibrate. Whereas on this controller, it's completely silent. Turned on, and you can't hear a thing, even if I... There is... Nothing. But the vibration motors still operate. So that's the magic of the pull-down resistor. Now let's get a closer look at the transistors and how it is connected. Right here is the input. It firstly goes through this capacitor so that it filters out the signal. Then it goes through this. This is, or not through, but it is connected parallel to this pull-down resistor. And here is the MOSFET, the transistor. And then here is the, again, the capacitor that is connected in parallel with 3.3 volts and the input, the output of the transistor, and then it goes to this board to wire connector, and this connector is for two vibration motors for the left side, and this on the right, and again here is basically the same setup for the right side. And it's quite simple. There are 4 of these setups, and there are 4 components in one setup plus the two connectors. Now let's see how it's connected in the schematic. Well, now we can see the schematic, and this is the left side and this is the right side. They are basically identical. Here it is connected the same way as we saw earlier. So it is connected with parallel with the 10 kilo ohm resistor and then 100 nanofarad ceramic capacitor. They are both connected to ground, and then the transistor is then basically the input is connected to the input or the gate pin of the transistor, and then the source is connected to ground and the drain is connected to the output. And there is also between the 3.3 volts and the ground is a 10 microfarad ceramic capacitor. So basically what we are controlling is the negative side, or the basically the ground path, so with this N-type MOSFET. And then for both the left and the right side we have one additional capacitor, again 10 microfarad capacitor connected between ground and 3.3 volts, just to help stabilize the current and the power. And a huge thanks to PCBWay, the sponsor of our video and the supplier and manufacturer of these fabulous PCBs. They provided me with these PCBs, basically refinanced them, and they're a great option to consider when building your custom PCB, whether you are a beginner or an advanced designer needing, for example, flexible PCBs or even a CNC manufacturing. They all have it covered. That's really cool, and they have awesome turnaround times. For me, this PCB took about 3 weeks, including the shipping from China to Europe. So that's, I mean, pretty great. For example, I chose in the first version, I chose this green, I would say a classic color for PCBs. It gives this retro 70s or 80s look where pretty much every PCB from back then was this silk screen color. However, they also have other options, and I chose this black one. They also have a matte black one that might be very, very cool as well. Don't forget to check out their website at pcbway.com, and it's also down in the description of this video. You can just click the link there and quick order your PCBs for your project. And the code is not even that complex, it's just 71 lines, so it's pretty simple. And right here we just include the Arduino library, and here we just define the pins for the outputs, or basically the inputs of the transistors. Here we define the inputs of the buttons, and here in the button state we just want to save the button state, whether it is on or off. And in the setup we are just assigning the whether the pins are output or input. And with the buttons I use input with pull up, so that it gives me clear high or clear low values. And also I just set all of the vibration motors to the default value of 0, basically turned off. And right here in the loop we just check whether the button is pressed or not, whether it is high resulting in true or whether it is low resulting in false. Then we just check it out, and if it's pressed then we apply voltage to the output pin, input pin of the transistor, and the transistor starts to conduct electricity, starting and powering the vibration motor. And we just do this for every of those 4 buttons and every of those 4 vibration motors. And combining the inputs from the buttons, the software processing and the hardware control with the vibration motors, we get the solution. And right here, again, each button controls separate motor. In the final scenario, it will be more like the Xbox controller, where the vibrations will be some kind of input for the user. But yeah, right here I just have it like a demonstration of both the buttons, so that the buttons are functioning, and also the vibration motors. And in the next video we can have a look at the software of the joysticks, or maybe the charger, or the audio chip right here, or maybe talk about the differences between the new 3.3 volt regulator, whereas this old and big 5 volts regulator. So don't forget to subscribe, there are a lot of things up ahead that require testing, and I will keep posting. And if you like this video, also don't forget to hit thumbs up, and bye bye!